So please enable your mic, sir. We are not able to hear you.
Can I able to see my screen?
Yes, sir. It's visible, sir, and you are audible,
Yes, sir.
sir. Yeah.
Yes, sir. Good afternoon to one and all presented here. So yesterday we have discussed about the basic concept of cyber physical power system, and today we will see the next topic: impact of cyber attacks in wide area control application of cyber physical power system. So we will first again we will see the basic of cyber physical power system. Then we will see what is the impact of this cyber attack in cyber physical power system. So yesterday we already seen this, the basic introduction of a cyber physical system. So the main background of the cyber physical system is three domain: computing, communication, and control. So these three are the main technologies behind this cyber physical systems. So computer science as well as the ECE and then EEE or ICE or E&I. So the computing communication control act as a triple C for the cyber physical system. So using this cyber physical system, we can connect or interact or intertwine the physical system as well as the cyberspace. So yesterday we have seen this the cyberspace, how we are connecting the cyberspace with the physical power system component. So the main concept of CPS is how we are bridging the two different domains. So next functions of three domains, computing. So the main concept of computing is sensing, analyzing, predicting, and understanding. So these are the functions will be performed by the computing domain. And for communication, we can do that interaction phenomena between cyber and physical, intervening and then interfacing management between the physical and cyber system. And then the last one is control system. So the main concept of control system is to create a intelligent control or autonomous system for this cyber physical systems. So overall, this computing, communication, and the control together will monitor and control the cyber physical systems. So what is the main complexity? The main complexity is how we are integrating the cyber components with the physical system. So this integration is not a easy task. So the two concepts behind this integration is intent dependency as well as the interaction between the cyber and physical systems. So because of this integration, interaction, and interdependency, it is increasing the complexity of the cyber physical systems. So therefore, we need some comprehensive knowledge. A knowledge base is required for this CPS domain. So before entering into the full details of the cyber physical power system. So this is the basic building block of cyber physical system. So computation, communication, and control. So these three technologies together form as a foundation for cyber physical systems. So now we are going to apply this cyber physical system in cyber physical power system, and then we will see how the impact of what is the impact of this cyber attack in a cyber physical power systems. So the formal definition of cyber physical system is it is an interconnection of computing and then devices interacting with the physical world. So this interconnections having a strong, complex characteristics between cyber and then physical systems. So the main objective of why we are connecting the cyber system to physical system is to regulate the behavior, that is to improve the monitoring and the control of the physical power systems. So that is the main objective of this cyber systems. So it will continuously monitor the physical power system and taken the control of the physical world. So that is the main function of cyber systems. So here the three components are very, very important: sensors, control, and actuators. So the sensor which will sense the signal, and then the signal will be passed on to the controller, that is a computation side. Again, the controller, that is the processor, will generate the control signal and which will pass on to the physical power system through actuator. So the components are hardware devices for the cyber physical system consists of the sensor, controller, and actuators, which is form a basic component of the cyber physical system. So after choosing this sensor, control, and actuator, next we have to focus on the embedded control systems. So the embedded control system is completely different from the conventional control systems. So which is strongly interaction between the cyber and physical. So that's what it is called as a embedded. So that means any changes in the physical system, it will immediately affect the status of the cyber system, and any changes in the cyber system, it will immediately affect the status of the physical system. So this embedding concepts which will be very well useful for whenever the application is very time critical and synchronization, we need to go for the embedded control systems. So developing the embedded control systems, the first step is we must know the complete mathematical model of the physical power systems. So unless we are not having the full mathematical model, we cannot develop the complete efficient embedded control systems. So before developing this embedded control, we must have a full system identification of the physical power system. And after that, we have to design the controller, that is a control law. Then this controller law will be implemented as a embedded control using some theoretical methods. So this is the basic step of controlling the cyber physical power system. So the next thing is after choosing the embedded platform, we have to the next step is how to implement this the feedback control system. So the implementation of feedback control system, what are the challenges associated with this? Means the first challenge is computing resources. So the first challenge associated with this is embedded computing, and second one, the limited availability of resources in terms of computing power, memory, as well as the timing requirements. So these are the challenges before implementing the embedded control system for cyber physical power systems. So compared to the conventional physical power systems, the cyber physical power systems mainly focus on, so what is the processor we are choosing for this applications, and then what is the timing requirement, and then the synchronization problem we are involving in this cyber physical power system. So the timing is a very important parameter in this cyber physical power system. So the next thing is a formal verification technique. So after developing the embedded control platform, so using the computer science concept of formal verification, we have to check out the algorithm, the working concept of the algorithm, and then before implementing this into a practical scenario, we have to verify using the formal verification technique. So this can be done by using the state chart or state flow method, as well as the finite state machine, extended state machines. So these are all can be used to verify whether the developed embedded control system is working as per the requirement or working as per the specifications. So this is called as a formal verification technique, usually used by the CSE people to check the safety critical application control systems. So the structure of CPS. So as you know that the CPS is nothing but a feedback control systems, whether it may be a wired or wireless systems. So cyber physical system is a adaptive as well as a predictive control systems. So you can see this, the physical system, which can be represented as a plan to process, or it may be any system. So our case, this is a physical power system. And then from the physical power system, using the sensor, we are monitoring the system, and then the signal is converted into analog to digital signal. Then the digital signal is forwarded to the cyber system. So the signal which is sensed by the sensor, which is purely analog signal, and the cyber system will accept only the digital signal. So we need the analog to digital converter to convert this analog to digital, and this signal is processed by the cyber system. That means a processor. So it may be a computation, software, algorithm, or any code. So after this, from the cyber system, we are getting the control signal. Again, this control signal is digital, but the physical system will accept only the analog signal. So we have to convert back the digital to analog signal, and then we have to apply that control signal to the physical system. So this is a simple structure of a cyber physical system. So now we are going to apply this cyber physical system to the power system applications. So instead of physical system, we are replacing this physical system as a practical or a one-line diagram of your physical power system. So now you can see this, the physical system is nothing but the bulk power systems. So which is nothing but the generation, transmission, distribution, and utilization. And the controlling elements are given for the each one. So that is the generation, which is controlled by the AVR, exciter, automatic generation control, and the power system stabilizer. And the transmission system is controlled by the FACS, HVDC, and wind farm based controllers. And then the last one, utilization, which is coming under the load setting control, AMI, or energy storage. So now these physical power systems are monitored by the intelligent electronic device. So through the IED, we are sensing the signal as well as we are sending the actuating signal. So the red color arrow, which indicates that the monitoring signal is taken from the physical power system and entering into the cyber systems. So inside the cyber system, we are having the three technologies. One is communication. That means to receive the signal, that is sensor signal from the physical power system. Then it will forward to the computing system. Then it will be move on to the control. After that, again, it will come back to the communication. So here, based on the status of the power system, the control signal will be generated. And then again, this control signal will be fed back to the physical power system through the IED. So the one thing we have to note this point is the red color, this red color indicates that this system is operating in the continuous time. And the bottom one, the cyber system, which is purely a digital domain. That means a discrete time. So both the systems are operating in the different domain. So we need to consider the co-simulation of combining these two systems. So that means a physical system operating in continuous time and a cyber system is operating in discrete time. So this system is called as a best example of a hybrid systems. So we need to combine the simulation of two different systems. That simulation is called as a co-simulation or combined simulation. So the next point is the attack. So you can see this in the physical power system. We know that the physical attack will be happen in the physical power system. So for example, line to line fault, line to ground fault, three-phase fault, lightning attack. So these type of faults are or attacks are is called as a physical attack. So similarly, in the cyber side, you can see this, the cyber attack will be happen within the cyber system, as well as the cyber attack will be happen in the signals transferring between the physical and cyber systems. So the two types of faults or attacks also completely different. One is purely based on the continuous time physical attack, and another type is a completely digitalized type discrete time attack. So this also having a two different behavior or different time in nature. So the next one is a importance of attack and security. So this system is the best example of a cyber physical system. We need to continuously monitor. That means detecting any type of attack happened in the system or not. So continuously we have to monitor not only the power flow or any type of physical parameter. So in addition to the monitoring of the physical parameter, we need to detect any type of attacks are intruding into the system. So once it is detected, we have to design the cyber security algorithm. So which is represented as a shield, that is the cyber attack shield. So we have to design the cyber security algorithm to protect our or prevent any type of attack entering into the systems. So in this, the coming slide, we will see the impact of cyber attack in this wide area control of power systems. So defining CPS and CPPS. So CPS means any type of systems, not only the physical power system, agriculture, transportation, water, oil and gas. So these systems are called as a physical systems, which is connected with computing, communication, sensing, and networking. So this is the formal definition of cyber physical system. And cyber physical power system means combining the physical power system with computation, communication, and control. So that is physical power systems with cyber physical technology. So that is called as cyber physical power system. So in this CPPS, there are two important terms are called as interaction and interdependency. So interaction means the effect of cyber system on physical system and physical system effect on cyber system. So both the systems will be affect the other system. So that is called as interaction. And interdependency means physical system. The power system depends on cyber and cyber depends on physical power system. So this dependency is called as a interdependency phenomena in cyber physical power system. So this interaction and interdependency, both the characteristics are completely different and opposite to each other. So we need to consider while designing the embedded controller for this cyber physical power system. So the next one is events. So this fault in the power system. So how we can we know that faults in the practical power system. Similar to that in CPPS we call it as a events. So this events means nothing but a fault in the physical grid. So whether it may be happen in the generator side or transmission line side, or any type of fault effect in the physical side. And the second one, events in the cyber infrastructure. So whether your software code may be corrupted or any malfunction in the control signal, and there may be a delay in the communication signals. So this event, this fault occur in the cyber infrastructure. And third one, the events will be occur in both cyber and physical. That means dependent events. So if any event, any problem occur in cyber, it will affect the physical power system, and any event occur in physical power system, it will affect the cyber system. So this event is called as a dependent events. So the fault will be occur in any one of these three cases is listed here. So the next one is coming to the main topic, impact of cyber attacks. Why we need to focus on this impact of cyber attacks? So the physical power system is we are connecting this power system fully with the internet technology. So the practical power system is more than the human operator. It is completely monitored and controlled by the internet technology. So that's why it is called as a cyber physical power systems. So after incorporating this 5G communication technology or 4G communication technology in the power systems, the grid monitoring and control is completely improved. So the whole power system is moved to the conventional system into intelligent as well as autonomous systems. So there is no doubt in that after incorporating this ICT into the power systems. But because of this information communication technology, so there is a lot of the opportunities for cyber attacks will be happen in this power systems. So one side we are moving to the advanced technology, and because of that advanced technology, we are facing this cyber attack in the power systems. So that's why we need to examine. So what are the effects of cyber attacks so that we can able to analyze or determine the degree of danger to the physical power systems. So using this by assessing the impact of this type of attack, we can take some preventive action so that we can make our system to be not to reach to the blackout conditions. So you can see this fourth point, the grid operators. So even though it is fully monitored by communication technology, the grid operators will allocate the sufficient resources to protect the power grid from any type of cyber intrusion or cyber attack. So this was a very, very important task will be performed by the current generation power system operators. So the last point is with the help of assessing the impact of this attack, we can always have some backup plan. So if anything happen to through the cyber attack, how we can make our power grid at least or very small effect on the power system. How can we save that remaining part of the power system? So that we can have some develop some backup plans once cyber intrusion will be happened to the power grid. So the next one thing is alternative power supply arrangements. So nowadays the evolvement of a microgrid. So nowadays a microgrid, next nanogrid came, and then a network microgrid also currently an emerging topic in the power systems. So because of this cyber attack in the power systems, alternate microgrid and alternate network microgrid also alternative absence once a cyber attack happened to the power grid. So because of this type of cyber attack, we are facing the losses and then danger to the public safety, dependability, and then security for the electricity infrastructure. So it is not only affecting the threatening to the power, it is as a country, it is affecting the economically damage to the whole country. So this is another issue we are facing this. And the cyber attacks morely attacking on the wide area control applications. So nowadays we are using the phasor measurement unit for wide area monitoring and control applications. So because of this PMU, we are having a synchronized grid from Kanyakumari to Kashmir. So the cyber attackers mostly focus on wide area control applications. So if they attack the wide area control, the entire grid will be moved to the blackout conditions. So the next thing is, after attacking the wide area control, the grid will be completely unstable and leads to the cascading failure. That means the one part of the system is affected by this cyber attack. It leads to the spreading of this outages to the next nearby area. So that's what we already always would be have this networked microgrid with the back support of main power systems. And then last one, what are the wide area control functions? So there are many wide area control functions which are carried out in the physical power system. So the first one is oscillation damping, voltage stability management, and then a transmission stability improvement. And then we have some cyber security measures in the wide area control applications. So these are all the functions are performed by the WAC, wide area control system applications. So once the wide area control is insecure because of this cyber attack, it leads to the violation of the stability of the power grid. So with this background, it is necessary for to assess the impact of a cyber attack on the physical power system. We need to assess or analyze if cyber attack happen means what are the characteristics will be reflected in the physical power system parameters. So the proposed work, the current research work we are doing is we are focusing on so we are focusing on analyzing all the combination of cyber attacks. So I will show that what are the different types of cyber attacks you can simulate in the physical power system. You can use the MATLAB. I will show that all the combinations. So what are the different possibilities of you can create the types of cyber attacks in the physical power system with the fax controller or HVDC or any type of wide area controller we can with the incorporation in the physical power systems. So after assessing that, the next step is we are going for a cyber security. How to detect that attack. So that is called as the cyber security systems. So by this cyber security technique, we can prevent any kind of threat will be entering into the systems. So the first step is we have to analyze what are the different types of cyber attack we can be simulated. Second one, we need to detect the types of attack. What are the types of attack intruded into the systems? After detecting the types of attack, we have to mitigate the attack so that we can prevent any kind of threat into the systems. So the last point is currently we are using the machine learning as well as the AI based method. So as you know that the data driven methods are very, very powerful and very intelligent in preventing and detecting this attack. So I am using this machine learning based concept as well as the deep learning CNN based algorithm for this detection and mitigation of these attacks. So this is the proposed work in this assessment of attack impact on physical power system. So the overview of the research work is my research work is the cyber physical power system is considered as a New England 39 bus systems. So as you know that the most of the stability of the systems we can tested using this New England 39 bus system, or the higher bus system means 179 practical WSC systems. So in the New England 39 bus systems, first step is to develop the mathematical model for cyber physical power system, and then to develop the mathematical model for different types of attack. So whether it may be a single and multiple types of attack, coordinated type of attack, as well as the attack impact on wide area control. So after completing this mathematical model, the next step is to assess the impact of attack on the power system parameters. So here I have listed the 5 parameters: tie line power, speed deviation, bus voltage, active power, and STATCOM voltage. So after the attack has happened in this power system, how these 5 parameters are influenced by this cyber attack. So the last one is detecting this cyber attack using this ML and DL algorithm. So for DL classifier, using the CNN convolution neural network, and the machine learning classifier, the K nearest neighbor and random forest and the support vector machine, and then validation using this the corresponding performance metrics for which one is very highly efficient in detecting this cyber attack in the power system. So this is the overview of the research work proposed for assessing the impact of a cyber attack on physical power system. So What is the main contribution in this work means I have developed the cyber physical model for a New England system with three attack scenarios. SCA means a single cyber attack, and MCA represents the multiple cyber attack. That is different types of cyber attacks attack at the same time, and coordinated means two attacks happened at the same time, so not at the different time, and also physical attack also will be joined together. That is called as coordinated cyber attack. So second one, the second contribution is impact of attack and wide area control application is completely explored, and we have analyzed the results from this New England Technical University system. And third one, mathematical model developed for the cyber physical power system, and then types of attack are developed. And last one, what are the impact of attacks on various power system parameters analyzed, and finally the attack is successfully detected using this four types of algorithm. But we are focusing now, this session focusing only on impact of attack on the physical power system parameters. So the mathematical modeling of the cyber physical power system is shown below. So you can see this. This is the model of a conventional model of the dynamic model of the physical power system. I hope you can. You already seen this mathematical model for physical power system. So using differential algebraic equation, we can able to develop this model, and this del which will be represents the angle, and then omega represents the velocity of the rotor, and E represents the EM of the generator, and PQ represents the real power and then reactive power, and the MD represents the inertia constant as well as the damping constant respectively, and this tau represents the time constant. So this is the basic the power system dynamic model using the differential algebraic equations. So with this physical power system model, the next we are moving to the state space model of this physical systems. So the state space model, which is shown here in equation 6, and then we are representing this physical system in the mathematical equation, that is y equal to h of x comma u, which represents the state and then input of this physical power system, and the u represents the input of the physical power system. So now we are having this the basic concept of this physical power system model. So one part, that is the 50% of the mathematical model of CPPS is over. So the next 50% is how to model the cyber system, because the cyber system only sensing the signal as well as generating the control signal, then it will send the actuating signal through IED to control the physical power system. So that is called as cyber system modeling. So the cyber system means is nothing but a communication, computing, and the control. So these three systems are joined together, but the communication network is completely modeled as so the k and eta of gamma. So you can see this the state of the cyber system, and the z n cy represents the state space in Euclidean dimension, and the eta represents the input signal for this cyber systems. So similar to the physical power systems, we have the separate cyber systems. So from the basic structure of the cyber physical system, we can connect this two different continuous as well as discrete time domain system through the communication interfaces.